Welcome back to College Algebra, and we're in this series where we're talking about the basics of college algebra. Today we're talking about simplifying fractions. So we're interested in taking fractions and turning them into other equivalent fractions. And as in other sessions, this is something I know you're familiar with, but hopefully talking through it will make you even more confident and even more comfortable with these ideas. Let's start with something that's very simple. It's a very simple process that I think will make sense to you, and it's that we have the fraction 2/3. Now, what's important about fractions is to realize that that there are multiple ways that we can represent the same amount. So 2/3 is simply just this amount, these two red marked places, parts of the circle. We had the circle, we divide into 3 equal pieces. 2 of those 3 pieces make it 2/3. Now what if, instead of dividing it into 3 pieces, I'd wanted to divide it into, say, 6 pieces, and I cut each of those pieces that I had in half. Now what would my result be? Well, notice the red amount is the same red amount as earlier, but what I get from my answer is now 1, 2, 3, 4. I now have 4 pieces highlighted. That is, I've counted 4 pieces. My numerator is 4. And now my pieces are all of a size 1/6, because there are 6 pieces total. So what we need to realize is that our 2/3 piece and our 4/6 piece is actually the exact same, because the amount, the red shaded area, is the same in both situations. I could have divided it even further. So what if I split each of those in half again? And then I would notice that what I have is I have 1, 2, 3, 4, 5, 6, 7, 8 pieces shaded red, and then I have 8, 9, 10, 11, 12 pieces total. And so this fraction could also be thought of as 8/12. So what we see is that when we took our original amount, which was 2/3, and which was 3 pieces, and we were counting 2 of them, when we subdivided those 2 pieces and made more and more pieces of the same size, we got equivalent fractions. And so we actually have 3 numbers here: 2/3, 4/6, and 8/12 that all are the same number. And this is kind of unusual for us because we're used to, in the world of mathematics, every number having only one way to write it, number 5, 6, 7, etc. But fractions are a little bit different because there are many ways to write a fraction, and here are 3 different ways. Now, this idea of taking a small fraction like 2/3 and subdividing to get larger fractions, this can go the opposite direction. So we can take a problem like this, where we have, say, 9/12, and here's a picture that represents 9/12. I have 12 boxes and I've shaded 9 of them. What we can do is we can take these boxes and group them together in groups of 3. So maybe I'll group these 3 together, these 3, and these 3 together. And what you'll see is that I get the exact same picture as 9/12, but this time we only have 1, 2, 3, 4 pieces. And now of those 3 pieces, of those 4 pieces, 3 are shaded. So 9/12 is the same as 3/4. Now what you probably want to realize when we think about this is something that I'm sure you already know and have already thought about, but it's that we can get between these numbers. We can go from these numbers 2/3, 4/6, 8/12 in the previous problem, or 9/12 to 3/4. The way we do that is by dividing and multiplying both the numerator and the denominator. And that's kind of at the heart of why these problems work out the way they do. So let's bring us to our basic principle. Our basic principle is that when we multiply or divide the top and the bottom of a fraction by the same number, we get an equivalent fraction. I'll try not to go through too much of an argument for why this should be true, but hopefully through these 2 examples it's somewhat convincing. In this example, when we've divided, we took our 12 and we put them into groups of 3, and so that means we've divided our 12 by 3 to get 4. So if I look at this situation, I would notice we had 9 divided by 12. I divided by 3, and then I ended up with 4 pieces, but I also had to divide my 9 by 3 because I was grouping my red blocks in groups of 3 as well as I grouped all my blocks in groups of 3. And so I get 3/4 by taking my 9 and divided by 3 and also taking my 12 and dividing it by 3. Notice on the previous problem we had our 2/3 and we doubled it, so we doubled our 3 so that we now had twice as many twice as many pieces, and so that gave us 6 on the bottom, but we also had twice as many red pieces. That gave us 4 on the top. So 4/6 is equivalent to 2/3 by multiplying both the top and the bottom by 2, versus this other problem where we divided both the top and the bottom by 3. What we really want to do is simplify fractions. And we want to do this by using our principle, which is that we can multiply or divide the top and the bottom of a fraction by the same number to get an equivalent fraction. And when we simplify, what we're generally trying to do is take this fraction and make it smaller by consistently dividing the top and the bottom by the same numbers over and over and over again to get ourselves the same fraction. Now, one possibility, one way to do this is just to look at these numbers and look for the common factors involved in these numbers. That is, look for something that divides both of these numbers individually and then divide both of them by it. And if you're like me, you look at this, you can quickly see they both have a 5 and a 5, so this tells me they're probably divisible by 5. So what if I take the top and the bottom and divide both of those numbers by 5 and get my new fraction? Let's see, 105 divided by 5. I'll let you work that out at home, but I'll tell you the answer. It's 21. Now let's look at the 175 divided by 5. I'll let you work that out at home, but I'll go ahead and tell you the answer. The answer is 35. And so we've successfully simplified this fraction 105 over 75 to a simpler one, which is 21 over 35. Now it might be that you realize we're not quite done, and the answer is we can make it even simpler. And we can make it even simpler by noticing that these two are both familiar because there are multiples of 7. So I can divide the top by 7, divide the bottom by 7, and then I get 21 divided by 7 is 3. 35 divided by 7 is 5. And so this complicated number, 105 over 175, simplifies down to 3/5. The truth is that there really is no difference between writing the number 175 or 75 or writing the number 3/5. They're both correct. They're both appropriate answers. It just seems that this number is a little bit easier for us to think about because our brains do better with smaller numbers than with really large numbers. So that's why we often work to simplify it. At this point, I would like to do what I often do to end a lesson, and that is I want you to try to simplify these two fractions. I'm going to ask you to pause your device, spend just a few minutes working on the problems, and then come back and let's see how we do. All right, thank you. We're back. Let's now try this first problem and see if we can get the correct answer on it. So I'm going to have 90 divided by 65, and the way, let's write it right up here. And so the way that I'm going to solve 90 divided by 65 is I'm going to divide both by 5 because I realize that 90 and 65 both have a factor of 5 in them. And so let's do that and see how that goes. 90 divided by 5, I can do that one. I realize that 90 divided by 10 is 9, and so this one should actually be 18. If you don't know it, you could work it out by hand, but this is a division that you need to be able to do. Similarly, 165 divided by 5, I noticed that I might go into 115. Tell you what, let's go ahead and do this by hand so we can see how it works the long way. We'll do 165 divided by 5. It goes in here 3 times. That gives me 15, and a remainder of 1, and then I have a 5 here. And then I get another 3 times, which is number 15. It gives me 0. So it looks like 33 is what we get for our denominator. So you have an 18 on top and a 33 on bottom. If I look at these, it might be tempting to stop, but we're actually not done. These are both divisible by 3. You could go and check, but they are. So I'm going to take both of these and divide them by 3 again. So divide both the top and the bottom by 3. When you divide 18 by 3, you get 6. When you divide 33 by 3, you get 11. Now we look at 6 and 11. 11 is a prime number. It's not going to have anything in common. 6 is, of course, not a multiple of 11. So we're all done with that answer. Okay, that's great, and that's exactly how we approach this problem. Now let's look at our second problem, which is 128 divided by 96. And let's see if we can solve this one. It's not obvious to me, just right off the bat, what is the first one that they both go into, but they are both even. So why don't we divide them both by 2 and see if that helps. Dividing 128 by 2 gives me 64. Dividing 96 by 2 gives me 48. Again, you could work those out using long division if you like. Now I notice that I still have two even numbers, so let's go ahead and divide by another 2. And we'll just keep doing this until we get down to where it's really simple. 64 divided by 2 is 32. 48 divided by 2 is 24. Okay, we're still both even, so let's divide by another 2. We now have 16 over 12, still both even. So we divide by another 2. 16 divided by 2 is 8. 12 divided by 2 is 6, still even. So let me come write that again. So I'll divide them by 2 one more time. And that's going to give me 4 divided by 3. And it looks like we finally reached the point where they don't have anything in common. So 4 divided by 3 is our final reduced fraction. I hope that went well. Good luck, and we'll see you next time when we talk about adding fractions.